Hello, and today we're going to talk about section 2.1, introduce the graph stuff to you. So the name of the section 2.1 is rectangular coordinates and graphs. So this starts a new chapter for us, and we switch our thinking to how things look on a graph. In the past, in chapter 1, we thought about graphing a little bit. We did the x-axis, just the horizontal axis, and we graphed things, looked for sections of the graph that solved linear and quadratic inequalities. So we did it a little bit, but in 2.1 we add the y-axis. So we have the x-axis, the horizontal axis, and then we also have the y-axis to think about. So just to review our rectangular coordinate system, again, this is the x-axis, this one is the y-axis, and then we grid it out like each are a number line. And in the middle is 0. We call this starting point the origin. So we have the positive numbers on the right and the negative numbers on the left, just like always at the number line. And then for the vertical axis, the y-axis, it's another number line. So we have the positive numbers above, the negative numbers below. When we list a point in this grid, we list it in order, so it's called an ordered pair. Because the order matters, we want to have the x always listed first and then the y. So say I plot over 2, up 3, this point. I would say that's the point x is 2, over 2 on the x, and y is up 3, positive 3. Another example, if I go back 2 and down 3, negative 2, negative 3, again the x is first, back 2, and then the y is down 3. Another example, over 1, down 4. That would be positive 1, negative 4. Again, positive 1 on the x, negative 4 on the y. Another, let's do one in this quadrant. Let's go back 2 and up 4. Negative 2, positive 4. So again, the x value back 2, the y value up 4. So there are 4 sections of our graph. We call those the quadrants, and they're in this order. They're counterclockwise, starting at quadrant 1, and then this is quadrant 2, quadrant 3, and quadrant 4. Sometimes points lie on the axis, like this point over 2, and then we would say 0 for the y. So 2, 0 would be not in a quadrant but on the x-axis. We could be on the y-axis. Here's the point 0 for x, 3 for y. So 0, 3 on the y-axis. All right, the next thing we're going to do in this section is talk about distance between points. So in this coordinate grid, if we were to draw a line between, say, this point 0, 3 and this point negative 2, negative 3, I'll call them back. But anyway, we could figure out the distance. We could sort of count the squares, but that wouldn't be perfectly accurate. So an actual way to do it is with the formula, the distance formula. All right, so our next note is the distance formula. And again, it's for finding the distance from point to point in the coordinate grid. And it's based off the Pythagorean theorem. Actually, we could talk about that, why that is so, but here is what the formula looks like to copy down in your notes. And it says if you want to find the distance between any 2 points, it's the difference of the x values in those points squared plus the difference in the y values squared. Again, x sub 2 minus x sub 1. Basically, just subtract your x values, square it, plus subtract the y values and square it, and then square root that final answer. For example, let's go back to my example. I had a point 0, 3. Then what was it? I've forgotten it exactly, but it doesn't matter. But let's say it's negative 2, negative 4, for example. And I want to know the distance between those 2 points. So we can plug it in this formula. It says subtract the x's, so I've got an x value of 0 and an x value of -2. Who's to really say which one's x2 and x1? So you really can subtract in either order. We could consider this the first point and this the second point, or really vice versa. It wouldn't matter in this case. But let's just say this is point 1 and this is point 2. So this would be x of 1 and this would be x of 2. So x of 2 minus x of 1 would be -2 minus 0, and then we're going to square that. Then we do the same thing with the y's. So this would be y sub 2 is -4 minus y sub 1, 3. -2 minus 0 is -2. We're going to square that. -4 minus 3 is -7. Again, squaring that. That's 4 and 49, which is 53. And then don't forget there's a big square root around all that. So that's square root of 53 is the most exact way to leave the answer. You could punch it in your calculator and get a decimal. It's about 7 point something, 7.2-ish. So it's a little more than 7 units from here to here. All right. So again, because we are subtracting and then squaring, it doesn't really matter what order you subtract these in. But this is just the traditional way this formula is always listed, x of 2 minus x of 1. But no, that's not really a big deal. The big deal is you subtract the x's, whatever your two x values are, you subtract those, square it, subtract the y values, square it. All right, so I'm going to give you a U try. Use that formula again. And you can pause the video to practice this. I encourage you to do that. I want to ask you to find the point between, I'm going to say a point P that is 3, -5, and we'll say a point Q that's at -2, 8. So again, pause the video and work that on your own. But I'm going to go ahead and proceed and work through this step so you can check your work when you come back in. So subtracting the x's would be -2 minus 3 squared. Subtracting the y's, 8. And notice there's a subtract in the formula and a negative on the number, so don't miss that double negative that happens sometimes. And then we'll square root that answer. So that will be -5 squared plus 8 plus 5 is going to be 13 squared. 25 plus 169. Punch that on your calculator. Let's see, that's 194. And that's the most exact way to leave the answer. What we learned back in previous chapters is if you have a radical that will reduce, you should do that. So if there's anything perfect in it, like a 49 you can divide into it, or 64, you should reduce your radicals. If requested to write as a decimal, you could type it in your calculator, but this is typically the best way to leave these. All right, the other formula in 2.1 that we want to know is the midpoint formula. So there's two big formulas and then one big idea in 2.1. The midpoint formula. So the middle between 2 points is this formula, x of 1 plus x of 2 divided by 2, then y sub 1 plus y sub 2 divided by 2. It basically, midpoint would be the middle of a segment. So if you're trying to find the middle between the x's and the y's, it makes sense to kind of average them. So the average of the x's, then the average of the y's. All right, the example we're going to do is I'm going to use the one in the book, which is, where am I? I am on example 5. Okay, we have a list of points at 8 and -4, and then at -6, 1, and it says to find the midpoint. So to find the midpoint, the formula says add your x's and half it, or average them. So this is an addition formula, 8 plus -6 divided by 2, comma, and then add the y's and half it. So that's -4 plus 1 over 2. So that gives us 2 over 2, it reduces to 1, and -3 over 2. I'll just leave it like that. So that should be the middle point of those two segments. I'm going to give you a U try. You can pause the video at this point to practice. All right, so find the midpoint between -7, -5, and -2, 13. The middle of those two points. So the formula says add the x's, so -7 plus -2 and half that. That's -9/2. I'll just leave it like that. And then do the same thing for the y's. -5 plus 13 divided by 2. Let's see, that'll be 8/2, which reduces to 4. And then the point, if we were to draw these out on that coordinate grid again and connect that segment, the middle of that segment should be at the point -9/2, which would be -4.5. So back 4.5 and up 4 should be the middle. You'd hit exactly the middle of that segment.